Are you planning to buy a telescope to observe the nice rings of Saturn? Well, let's see if currently is the best time to see the rings at all. Hi everybody, Thomas here and welcome to another Compressed Cosmos coding video. Today we are going to answer the question whether it's the perfect time currently to buy a telescope if the only purpose is to observe Saturn and its beautiful rings. Now the rings are is a very small, let's say almost donut-like thing around Saturn with rocky and especially ice objects that are reflecting the sunlight. And it looks really beautiful in all these nice telescope images, and even from Earth with a good telescope you can even see them with the naked eye. However, let's take a look at this small animation I did with Stellarium to see how things behave over time. Now you see in this small video I increased the pace also a little bit. It's a time range from this year, so 2024 to around 2050, how the angle between the ring and Earth changes. Now today we have more or less an edge view, so it's not really the perfect time, but it's improving over time, and you see also that the angle is increasing, but somehow we are observing the ring from below in a way. So I would say let's switch back to me, and I would say let's switch to Python and see how we can answer the question when the rings are in a perfect constellation for us to observe from Earth. Now before we start, I would suggest to go to my GitHub repository to show you where all the coding is. Now the good thing is we do not need to install anything. Everything runs in Google Colab, so you just need a Google account. And the link to my repository is in the description, and I would be also very grateful if you could give me a small star to favorite my repository. Now at the very top you see the folder Compressed Cosmos. We simply click on this, and there we have the two files Saturn Rise from the last video that is linked here, and now today's video Saturn's Ring. Now if we click here on this Jupyter notebook and it's loading, we see a short description, and we see here a small badge called Open in Colab. Now if we click on this, then Google Colab is opening automatically, and the good thing is that you just need a Google account and you do not need the paid subscription. You can also work with the normal subscription that is for free. So this is a very good thing, and I would suggest let's start with the script. The very first thing is we have to run the installation of FM and of Google Colab gives you a small warning if you start some scripts from GitHub. There can be malicious code and so on, but you can go through my code and see there's no malicious intent in the coding. Now first of all it tries to connect to some kind of free capacities, and then it will install the library via pip. Now this takes only a very few seconds. A lot of libraries are already installed per default, like NumPy, like Matplotlib and what have you, but FM is very special for astronomy, and it's not a default library that's running natively on Colab. Now this is working now, perfect, and we can go to the second cell, which is the entire code that consists of two functions and a main part. The very first function is called Saturn Ring Tilt, and it expects some kind of date time object, but if there is none, then well, the current date time is being used. And what does it do? It uses FM here in this part to compute the all the information of Saturn, so where it is, you know, the right ascension, the declination, so the position at the sky, and all the parameters. But the good thing is for the ring plane tilt, or as you can say maybe inclination, we do not need any heavy computations because the library is doing this for us, which is pretty nice. So we can simply extract the information of the ring with Saturn.Earth tilt. So Saturn is our object, our Saturn object that we created here in line 16. And now we have the ring inclination in radians and we have to convert it to degrees. And this is basically it. So it's very, very simple. The library does everything for us. And now in our main script, we switch this function here. We skip it quickly. We compute first of all the current tilt, and then what we do is we want to compute different angles at a certain starting time until an end time. In this case here you see it's from now on until now plus 520 weeks, so around 10 years. And this is also the two input parameters the function Saturn ring tilt evolve expects. Yeah, so you see this here, the function in line 26 is that it needs a start time and an end time, the datetime object, not the string format or something like that. We create some empty arrays, and then we go through our first function where we compute the tilt for different times. Now what we do here is we have the starting time as the variable time, and this while condition runs until the end time is reached, so time has to increase steadily. We have here a resolution of 1 week, so after each computation we add 1 week to this time. So as you can guess, after 520 weeks we have the condition that the time reaches the end time, and then we leave the while loop. And here for each time we compute the tilt angle, and then we append the angles and the time and return both arrays. That's basically it. So it's pretty simple here, and only around 30 lines of code with some comments we create all these things. Now the good thing is we can then use the angles that we computed here and create a small plot. So we have here the simple matplotlib call. I like the dark background, you know, dark mode, so I use this one here. And then the simple plot, we have the date time on the x-axis and the angles on the y-axis, some colorings, adding a grid, some x and y label, and then plotting it. So if we just simply press on the play button, it only takes less than a second, and then we can take a look at the result. First of all, we see the current tilt angle 1.99 degrees, which makes sense. I would say it's very edge on when we compare it to the beginning of the animation. And then you remember that the angle increased over time, but from below, so the angle should be negative, and this is also what we see here on the x-axis, the date time, or in this here it's been sampled down to years, and here the angle. So we have like a complete edge view the first quarter of next year, I would say, and then it improves. Yeah, we get again the visibility of the rings. So if you really want to have only a telescope for the Saturn rings, then you have to wait for a few more years before, let's say, astrodynamics and physics allows us to observe the rings again. Well, that's all for today's Compressed Cosmos tutorial. Thanks for watching. If you like the video, feel free to subscribe to my channel, and until next time.